a vector equilibrium, not in a static form, but a vector equilibrium as a change in density, meaning the vector equilibrium has this property in which it produces angular momentum in terms of its collapsing vectors. The way what Buckminster Fuller called the jitterbug, right? So I wish I had a jitterbug here. Actually, I do. So think of this. So there's the vector equilibrium, right? Or the cube octahedron, if you like. And you can see that, like, if I rotate the top clockwise and the bottom counterclockwise, it will collapse, right? You see the rotation that occurs, right? So imagine, so you have a field that has, so you can imagine, so look at the volume here and look at the volume here. And by the way, by the time it's gone from there to there, it's gone through the octahedron, the icosahedron, and now the dodecahedron, right? And so you have the tetrahedron, you have all the 5 platonic solids being produced, everything we see in nature being produced through just this motion, right? So you can imagine, like, now, as this collapse, if I had other ones that were attached to it, I don't know if I can do this. This is why the animation was so good. If you have other ones that are attached to it, that one would have grown when this one collapsed, right? So you have a change of density that's continuously occurring in a continuous information network, right? And so, and it's producing torque, right? It's producing torque in the field. So you have a density gradient. Think of the Planck field as being the densest. It's funny because we think of it as the vacuum, which when you think vacuum, you think it's really empty. But actually, it's the densest field, right? And it's triangulated, so it's cube octahedrons. And then you have density change all the way to the galactic and then universal level. And at the universal level, it's 10 to the minus 30 grams per centimeter cubed. So you've got a huge change of density, right? That's occurring. So think of, like, huge ones of those, right? Doing the thing at the universal level, but then smaller and smaller and smaller ones doing it all the way through the fractal structure, all the way to the Planck field, right? So the torque is continuously doing this thing to it, right? The density change.